last two cases, we were discussing the concept, the common perpendicular last time. At the back. Okay, so we were discussing a concept last time, the common perpendicular, when we discussed that if two vectors are multiplied through cross product, the result is a vector, not a scalar value. The result is a vector. So that product that results in a scalar value is called a scalar product, which we have done last year, dot product. We are now doing what is called vector product, the cross product that results in another vector. And we also discussed that that vector is mutually perpendicular to the two vectors that are being multiplied. And we also had a brief discussion on how I cross j becomes a k and j cross k becomes an I. Because if I take the cross product I and j, so the only vector which is perpendicular to both I and j is the k vector. So I cross j gives you k. If you remember this format, you will not go wrong. I cross j gives you k, j cross k gives you I, k cross I gives you j. And if you go in the reverse sense, then the resulting vector is going to be negative. J cross I will give you minus k, I cross k will give you minus j, and k cross j will give you a minus I. So if you remember this, you can't go wrong. So there are two ways of approaching the cross product. I'll first do the regular way, and then I'll give you a shortcut through the matrix method. Let's do the regular way first. So let's say you have 1, 1, 1, cross multiplied with minus 2, 1, 3. Let's say. So, just like any other product, every component gets to multiply with every other component in the other multiplicand. So, 1 will multiply by minus 2, then 1 will multiply by 1, and then 1 will also multiply by 3. But the thing is this, we already know that cross product of similar vectors is a 0. We already know that I cross I, j cross j, and k cross k are all 0. We already know that. We already discussed that. The reason why they are 0 is because the angle between them is 0. So, 1 times minus 2 is going to be a 0, 1 times 1 is going to be 0, 1 times 3 is going to be a 0. So, all the other multiplications are the ones that we are concerned with. So, 1 times minus 2 is a 0, then 1 times 1 is a 1, but here what is being multiplied? 1 what? I, j or k? See, that will be decided what are you multiplying with. See, here this is an I, this is a j, this is a k. So, let me write I, j, k. So, you multiplying an I with a j. I cross j gives you, so this is going to be a k. See, first I multiplied this with minus 2, I cross I is a 0. So the first color component is 0. Then I multiply I cross j. I cross j is a k. 1 times 1 will give you the value, I cross j gives you a k. Then you move on to the next one. 1 times 3 is a 3. I cross k is a minus j. So this is going to be a minus j. Then we move on to the next component number. So next component, 1 times minus 2. 1 times minus 2 is a minus 2. Now this is j times I. J times I is a minus 2. So minus 2 into minus 2.
समझ गया.
Yeah, this is the regular way of doing it. Once I do this, then I'll show you a shortcut as well. But you should know this. Whether you apply this in the exam or not, that's up to you, but you should know this.
Sir, ये वो वाला तो नहीं है, matrix वाला होता है.
नहीं, matrix नहीं, matrix वाला बता. Okay. Now, कौन सा वाला? ये है ना? J cross I is minus k. Minus j ये था. J cross j. I cross j. I cross j is a k. Then I cross k I cross K is a minus J. Then we're moving on to this one. J cross I is a minus K. J cross J is a 0. So no need to write, just write 0 if you want to. Then J cross K. J cross K is an I. So 1 times 3 is a 3I. Okay, move on to the next one. K cross I. What is K cross I? K cross I is a J. 1 times minus 2 is a minus 2. This is a minus 2J. Then K cross J. Let's check. K cross J is a minus I. K cross J is a minus I. So this is going to be a minus I. 1 times 1 is a 1. Minus 1I. And then K cross K is a 0. So your cross product is actually giving you
2I minus 5J.
It's 2I
minus IJ
minus 5J
plus 3K.
plus 3K. Yes. This is what you're getting here as a cross product. And this resulting vector 2I minus 5J plus 3K is mutually perpendicular to 1, 1, 1 and minus 2, 1, 3. Actually, this was a regular method. I know this is a tedious method and I'm not even suggesting that you do this in the exam. I'll show you another computational way of getting the answer. This is the definitional product. This is like a definitional procedure, I should say. And there's a computational procedure. So, but you should know this as well because the concept of I cross J becoming K and the concept of J cross I becoming the minus K, you should know this. Okay, the alternate way, which is the way I suggest you should do in the exam. So your cross product is 1, 1, 1 cross minus 2, 1, 3. What you do is you make a 3 by 3 matrix. First row you write I, J, K. In the second row you write the first multiplicand. By the way, the order of the multiplication matters in cross product. So I'm talking about the first multiplicand to be laid down as the second row. So 1, 1, 1. And then you write the second multiplicand as the third row, which is minus 2, 1, 3. Are we okay here? First row is IJK, second row is the first multiplicand, third row is the second multiplicand. Now, this is something you haven't done in O levels. We're going to find the determinant of a 3 by 3 matrix. You haven't done this in O levels, but let me show you how to go about that. What you do is, you take the first element and you disregard that row and that column in which that first element exists, and you take the elements, the leftover elements, and make it a submatrix. So this is how you go about it. So this determinant is equal to we're taking the first element I, so you write I, and then you make a submatrix which would be a 2 by 2 matrix of the leftover elements after disregarding that row and that column. So which would be 1, 1, 1, 3. This one, right here. Are we good? Okay. Next part, what you do is you write a minus the second, minus part of the formula by the way, minus the second element, which is J. Now this time you disregard that row and that column in which J exists, and the leftover elements make up one more submatrix. 1, 1, minus 2, 3. 1, 1, minus 2, 3. Is everyone with me till here? Any questions? Then plus, it's plus, minus, plus, that's part of the formula. Plus, minus, plus. You take the other element in the first row, which is K, and then remove that row and that column, and the leftover elements become another submatrix. Are we okay till here? Now, I think you know how to do a determinant of 2 by 2 matrix. If you don't remember the determinant of 2 by 2 matrix, very simple. Let's say this is your 2 by 2 matrix A, B, C, D. Determinant is cross multiply the main diagonal minus the secondary diagonal, and you get the answer for the determinant. So same way we do over here. 1 times 3 is a 3 minus 1 times 1 is a 1. This would be the I component minus determinant of this would be 1 times 3 is a 3 minus 2 times 1 is a minus 2, so this becomes plus 2 plus 1 times 1 is a 1 minus 2 times 1 is a minus 2, so this becomes a plus 2. Okay. And I guess we're ending up with the same thing. 2i minus 5j plus 3. I'm pretty sure you guys will use the matrix one.
Yes, sir.
Is everyone okay with the procedure? This requires a bit of practice, but as long as you understand the procedure, then you can go home and practice it. You can just randomly take vectors and just do multiply them and practice it. Any questions? Yeah. Yeah, this is the computational procedure where you get it. That was the definitional procedure. That's by definition how vectors should be multiplied, but anything should be multiplied for that matter.
Sir, is this possible in the calculator matrix or vector form?
I've never tried it, but they would expect you to do this one.
Yeah, we'd obviously do it, but to check the answer sometimes.
I don't know. Maybe there is a way in the new ones. I haven't tried it out. Okay, now this concept will lead to the next case. I think it would be case 8. Case 8, right? No, this is not a case. This was a concept. This is not a case. 8. Okay, case 8 is equation of a plane with 3 known points. Equation of a plane with 3 known points. So the scenario is this: all you know is that there is a plane and there are 3 points on the plane. That's all you know. You don't have the normal vector, you don't have anything. Now, to form the equation of a plane, you need only 2 things. You need a point and you need a normal vector. You need a point and you need a normal vector. Okay. So the procedure is pretty simple. You will take the 3 points on the plane and you will construct 2 vectors from those 3 points. Now, because those 3 points are on the plane, the 2 vectors that you will construct using those 3 points, they will also be in the plane. When you will take the cross product of those 2 vectors, you will get a third vector which will be mutually perpendicular to those 2 vectors. And because the vectors are in the plane, the result of the cross product will yield a vector which will be perpendicular to the plane as well. And that would be a normal vector. You use that as a normal vector, take any one of the 3 points and you form the equation of the plane. So, the procedure starts with step 1. Construct 2 vectors using those 3 points. Construct 2 vectors using the 3 points. Using the 3 points in the plane. Construct 2 vectors using the 3 points in the plane. Then take the cross product of the 2 vectors. Take the cross product of the 2 vectors, which would result in a third vector, perpendicular to the plane. In brackets I am writing normal vector. Take the cross product of the two vectors, which would result in a third vector perpendicular to the plane. And because the third vector is going to be perpendicular to the plane, it's going to be the normal vector for it. Then using any one of the 3 points and the calculated normal vector, form the equation. Using any one of the 3 points and the calculated normal vector, form the equation of the plane. Now it depends on the question. Is the question asked you for the vector equation or the Cartesian equation, then you form the equation accordingly. Using any one of the 3 points and the calculated normal vector, form the equation of the plane. Alright? Let's take a scenario. Let's say there is a plane. There is a plane pi and there are 3 points on it. Point A, point B, point C. Let's say point A is 1, 1, 1. Point B is 2, 3, 1. And point C is -2, -1, 2. That's it. Just bring it up.
So, can plane bend?
No, plane is supposed to be a plane. No, a surface bend. Plane. That's why it's called plane. The surface can be a curved surface or a planar surface. Okay. So step 1. Yes. Form 2 vectors using these 3 points. So you're free to form any 2 vectors. I'm for the moment forming vector AB and vector AC. Let's see. But you can form vector BA, BC or CB and C or whatever you want to do. Maybe BA and CA, whatever. Any 2 vectors. So my vector AB would be B minus A, which would be 1, 2, 0, and my vector AC would be -2, -1, 2, 1, 1, 1. That would be -3, -2, 1. That's my AC vector. That's your step 1. Now once you have these 2 vectors, we will use the concept of cross product to get a third vector perpendicular to the plane. So the next part is you need to take the cross product of these 2 vectors. Get a normal vector for your plane.
So the normal vector will be negative, right?
It could be negative or positive, doesn't matter. As long as it's perpendicular to the plane, that's what we're concerned with. So all of us, we get different normal vectors using different vectors. See, I used a combination of AB and AC. You might use AC and BA. Someone might use CB and CA. But all our normal vectors would seem different, but all our normal vectors would be scalar multiples. Because all the normal vectors have to be parallel to each other if they're all normal to the same plane. So, okay, I'm using the matrix method. I, J, K. Write the first vector 1, 2, 0. Write the second one -3, -2, 1. Let's go over the procedure again. So you take the first element, and you disregard that row and that column and take the leftover elements into a submatrix 2 0 minus 2 1. Check. Is everyone okay with this? Then minus j is the second element, minus is part of the formula. Disregard that row and that column and take the leftover elements, which is 1 0 minus 3 1 1 0 minus 3 1 and form a submatrix plus the third element k and leftover 1 2 minus 3 minus 2. No one should be getting this. Now we all know how to get a 2 by 2 matrix determinant. So equal to 2 minus 0 minus 1 minus 0 plus minus 2 plus 6. Check.
2i minus j plus 4.
Minus j plus 4. That's our normal vector. So let me just write this here. Our normal vector is 2 minus 1 4. Now, this would be the case that once you're done with all this and your answer comes out in very, maybe your answer comes out in very big numbers. So if that happens, just like I told you that you can take a reduced scalar multiple for a direction vector, you can do the same for the normal vector. If your numbers come out big, you can reduce it. If there is some common that you can take out or something, if it's coming out in fractions, you can always multiply it by a number and make it into an integer. So you can get a simpler scalar multiple and use that as a normal vector.
So it's minus 6.
What's up?
Minus 2. Minus 2 minus 6.
Lenny, minus 2 minus 6 plus 6.
Yes, yes. What if you minus 2?
It's primary diagonal minus the secondary diagonal. So it's minus 6. Yeah. It's minus 6. Okay, now step 3. Yes. Step 3. Use any one of the points and construct the equation for the plane. So you know it's r dot n equals a dot n. So I'm starting with the vector form. R dot n equals a dot n. It means r dot n is 2 minus 1 4. A is any point on the plane. Let's go back and pick up a convenient. I think 1 1 1 is a good point to take. So I'm taking 1 1 1. So 1 1 1 dot 2 minus 1 4. So the vector equation of the plane
2x minus 1 plus 4 is equal to 5.
4 plus 2 6. Yes. So this is your vector equation of the plane. And if let's suppose they ask you for the Cartesian, then directly you can just write 2x minus y plus 4 is equals to 5. That's the Cartesian equation. Are we good till here? Any questions? Any confusion? एक case right here. Last case. ये आ जाएगी.
सही है लास्ट केस पे तो चैप्टर खत्म है लास्ट केस
Last case.
चैप्टर खत्म
Okay. done with this. Last case step, we'll be done with this chapter. Case 9 line of intersection between two planes. Line of intersection between two planes. So the idea is this: when two lines intersect, they intersect in a common point. When two planes intersect, they intersect in a common line. So the best example that I can give you is of this book. Consider the two sides of the book as two planes, two non-parallel planes that intersect in a line. So the spine of the book is basically the line of intersection between the two planes. So the question that will come would be that they would be interested in finding the equation of this line. Now, how do you find the equation of the line of intersection if two plane equations are given to you? That's how we're going to go this procedure. So the first thing you need to do is to find the equation of a line. What two things do you need?
Fixed point.
You need one point and a direction vector. Alright. Now let's say you don't have the direction vector, then what do you need? Then you need at least 2 points. So in 2 points से आप पहले direction vector बनाओगे, and then from the direction vector, using any one of the points, you will make the line equation. Okay. So your first step is to solve the two equations of planes simultaneously to get 2 points of intersection. That's your first step. Now, the problem with the plane equation is that the plane equation is in 3 variables. And you have 2 equations. So the number of variables is more than the number of equations. So how do you go about solving 2 equations simultaneously with 3 variables? What you do is, you will assign a convenient value to any one variable of your choice. Let's say you assign x as 0. So in both equations you will assign x as 0. So the equation will come down to 2 equations only in terms of y and z. X खत्म हो जाएगा उसमें से. Once it's only in terms of y and z, you can solve the 2 equations simultaneously, get the value of y and z. You already have the value of x as 0 that you plugged in. You have that point of intersection. Repeat the procedure with a different value, and maybe you can use a different variable this time. Again, come down to 2 equations with only 2 variables, solve them simultaneously, get another point of intersection, you have 2 points now. With the help of those 2 points, just construct the vector equation of the line. So, step 1, assign a value to any one of the 3 variables in both equations. Assign a value to any one of the 3 variables in both equations. Then solve the two variable equations simultaneously. Solve the two variable equations simultaneously. Now the 2 equations have now come down to 2 variable form, because you've already assigned one value to one of the variables. So solve the two variable equations simultaneously and find the common point of, and find one common point, rather I should say, and find one common point of intersection. And find, because there are millions of points of intersection, find one common point of intersection. Then repeat step 1 with a different value of the variable or a different variable altogether. So you repeat step 1 with a different value of the variable or a different variable altogether. Then repeat step 2 and find another point of intersection. Just repeat step 1 with a different value of the variable or a different variable altogether. Then repeat step 2 and find another point of intersection. Once you have 2 points of intersection with you, then it's just constructing the vector equation with the 2 points form the vector equation of the line of intersection. That you know how to do. That's case 3, I think, or case 2 of lines provided on line. With the 2 points, form the vector equation of the line of intersection. Are we good? Okay, let's take an example. Let's say there are 2 planes. This is plane 1 and this is plane 2, and this is the line of intersection between the 2 planes. And what I am interested in is getting 2 points on this line. That's what I am interested in. So let's say the plane equations are x plus y plus z equals 5 and minus 2x plus y plus 3 equals 10. Let's say these are the 2 equations. Now, what's your step 1? Assign a value. So I'll say let me make this another value. Let me make this 3z. Okay, let's say let x equals 0. You can put any value, 1, 2, minus 3, 500, whatever you want to put. I think 0 is a good value to keep, so I'm just putting x is 0. What does this result in? It results in 2 equations with only 2 variables. So this will be y plus z equals 5 and y plus 3z equals 10. Right? Now, can we solve these 2 equations simultaneously? Give it to me in fractions. 5 over 2, which one? C is 5 over 2. And y?
More than 5 over 2.
That's fine. Y is 5 over 2, Z is also 5 over 2. Okay, so one point of section we have with us is 0, 5 by 2, 5 by 2. Are you okay with this? Can we repeat the process and get another point intersection? Let's take a different value and let's choose a different variable. Let's take z as 0. I'm taking z as 0 this time. Or you can put z as 1, 2, whatever you want. So the 2 equations that I'm getting now are x plus y equals 5 and minus 2x plus y equals 10. two values, x and y. X is
So x is minus 5 upon 3 and y is 10 upon 2.
20 upon 3, 10 upon 3.
20 upon 3.
20 upon 3. So the another point in the section is minus 5 by 3, 20 by 3 and 0. Are you okay with that? Now you have 2 points on the line. How do you form the vector equation of the line? First find the direction vector using the 2 points.
And then just plug.
Next step is get the direction vector using the 2 points. 1 point minus the other. Five by 2 minus 20 by 3. Minus 40. Negative, yeah, 25. Negative 25 is 6, and the other one is 5. Okay, like I said, let's take a simpler scalar multiple here. We don't have to use this. Can you multiply some value and make it into integers?
6.
Let's multiply by 6. So the direction vector that I would want to use, multiply this whole thing by 6, 10, minus 25, and 15 I guess.
Yes, sir.
Okay, we can further reduce this.
2 minus 5, 3.
Yes, I'd rather use 2 minus 5. Simplest scalar multiple. You have the direction vector with you, take any one of the points, I'm using this one, and form a vector equation. Please don't accidentally, don't change the point. You can change the form of the direction vector, not the point. You can only do this with the direction vector and the normal vector.